Hello and welcome. Today we're going to be covering lesson 11.2 in your Algebra 2 books, which is about probability. Oops, wrong way. There we go. First thing we're going to talk about is experimental probability, which where we take the probability of an event, and that's how we write probabilities P and then parentheses event, and that could be anything like probability of a heads for flipping coins, right? Or probability of, anything that you're looking for. This comes from two things. One is number of times the event has occurred, and then on the bottom is the number of trials or total times. So for example, if I was finding the probability of heads, right, say I flipped the coin 25 times, I got 12 heads. If I divide that into a percent, I will get 48%. Right, so that would be the experimental probability. Some of you guys might be saying, well, I know that flipping a heads is 50%, so you must have did it wrong. Well, experimental probability isn't the exact probability, it's just the probability of what we've known so far. This number, this percentage will get closer and closer to the known probability of like 50% with the more and more trials we do, but with only 25 trials, it might be a little bit off one way or another. So first thing we're going to do is talk about that. So we have problem 1 in your books. We have 60 vehicles in the teacher's parking lot. 15 of them are pickup trucks. We want to know what's the experimental probability that vehicle in the lot is a pickup truck, right? So first thing I'm going to write probability of a truck. So everybody knows what we're trying to find here. Then from there I'm going to use my experimental probability. On the top is the number of times the event has occurred, which there was 15 pickups. So the event has occurred 15 times. On the bottom is the total amount of trials. Well, that would be the 60 because that's 60 pickups or 60 vehicles, in the parking lot. Then I can divide those, right, and make them into a percent. So 15 divided by 60, well, that is going to be 25%. There's a 25% chance this vehicle in the parking lot is a pickup.
You have boxes in the office.
Next we're going to cover some vocab words. Sample space is all possible outcomes. So for example, in the last problem that we did, it would have been all the vehicles in the parking lot. So that would have been the sample space. Right. Here, I'm going to give you guys some examples of a sample space. So if we're flipping a coin, the sample space is either heads or tails because that's all the possible outcomes, right? Either heads or tails. So let's think, what's the sample space of rolling a die? Well, it kind of depends on what type of die you have. Most of the die are six-sided, right? A six-sided die that you play like Monopoly with. So the sample space here would be numbers 1 through 6. All right. What is the sample space of a letter grade of quarter 4? All right, so what's the sample space there? Well, your options, not really options, but what you can earn are an F, a D, a C, a B, and an A. So that's the sample space there. All right. What's the sample space of Stanfield phone numbers? All right. Well, they all have the same prefix. So our sample space is going to be numbers 0000 through 9999. Those are all the numbers that could be in Stanfield. Right. Now, equally likely outcomes is something we need to talk about, and it's when each outcome in the sample space has the same chance of happening. Some examples of that would be this first one we talked about, which was rolling a die, right? Most die, unless you buy a trick one, will have the same likelihood of rolling a 1 or a 5 or a 6 or a 3 or a 2. So that's going to be equally likely. Also, if you randomly punch some numbers in the phone, those ones will be equally likely. Now let's talk about something that's not equally likely. And I'm looking at the letter grades here, right? Because not everybody, not the same amount of people get each grade. Usually there's more B's, right? There's a lot of B's, some A's and some C's, and then not so many D's and F's. So that one is not equally likely because you're more likely to get C's and B's than F's and D's. All right, a simulation is a model event. Sometimes you don't have time to go out and count all the cars, so you have to make a simulation, and it will save yourself some time, and you can still find the experimental probability. So here we're going to be using a simulation on our calculators. Okay, on a multiple choice test you have 4 choices, right? Usually A through D, but only one will be correct. I want to know what's the probability that you'll pass the test by guessing at least 6 out of 10 answers correctly, right? So 6 out of 10 answers correctly. So we want a 60% on our test, but we're just going to Christmas tree it, right? So what I want you to do is go to your calculators, right? And I'm going to go ahead and get there we go. So I cleared it off my space here. And what I'm going to do is use some simulation stuff. Now, this is what a calculator is really good for. And what we're going to do is we're going to type in, this is going to be more difficult than I thought. All right. So what we're going to do is we're going to type in, there we go. There it is. We're going to type in rand, which stands for random, right? Rand for random, and then int, that stands for random integer. Okay, we're going to be dealing with random integers, and then I want a parenthesis, and then I'm going to type 1, 4, 10, and then end the parentheses. Okay. Now this tells the calculator some things, right? One, it says I want it to be random. Right? I want it to be random because of we're guessing, right? So there's no thought behind these answers. I want it to be an integer, which means I don't want any decimal points. I want the numbers to be between 1 and 4, and I want there to be 10 total guesses. All right. So let's see what this looks like in. Right. So now I'm going to hit enter, and it's going to give me 4, 4, 1, 3, 2, 3, 1, 2, 4, 1. Right. So it gave me a bunch of random numbers. Now the way we can think about this is by saying the random integers that are 1s are going to be the correct answers. And then the random answers or random numbers that are 2, 3, and 4 are answers that are wrong. And if it helps you think about it, 1 would be right, 2 would be the next closest, 3 would be the third closest, and then 4 would be the furthest answer away. The most wrong one. So here I got 3 1s, which means I got 3 right out of 10. All right. So let me see if I can close the ink layer and then. Oh man. Okay, so that one we got 3 right? So we had 3 out of 10, which is a 30%. All right. So on that guess right there, we got a 30%. Now from here, that's only one simulation, so we can't really say it's always going to be 30% yet. So let's come over here and let's just hit enter again, and it'll redo it for us. So now I get a new one. If we count, we have 1, 2, 3, 4. We have 4 ones, which means now we have a 40%, right? So we had a 30%, a 40%, this one here, we have 1, 2, 30% again. Right? And the more we do, the closer our experimental probability is going to be to the real one. Right? So now I'm going to hit enter, and let's do like 3 right now. So I'm going to hit 1, 2, 3. So on this one here, we have 1, 2, 3. So this one's a 30%. This one, the one right below that is 1, 2, 3, 4. So this one's 40%. This last one that we just did, 1, 2, 3, 4, 5. So that one's a 50%. Best score so far, right? All right, so a 30, 40, and a 50. So a 30, 40, and a 50. And we haven't even passed the test once yet. We've taken it 6 times, been guessing. We haven't passed it once. So let me try, let's do 3 more. 1, 2, 3. So we're looking at these bottom 3. This one's a 10%. This one's a 20%, 10%. So we want 10%, 20%, 10%. So let's go back. Three more. We have a 10% here, 10%, 0%, and 1, 2, 3, 4, 40%. Oh, I forgot what they were already. 10%, I think it was 10%, 0%, and 40%. 10%, 0%, and 40%. Now, if we look at what we have now, right, our probability of a pass is going to be equal to, on the bottom we're going to have the total sample space, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. On the top is the number of passes. Well, we have 0 passes. So 0 of 12 is 0%. Now, some of you might think, hey, it can't be 0%. At least one time I'll accidentally luck out. Well, we could keep on doing these simulations and keep on writing down more and more percents here until eventually we get one that passes, and then it'll give us a little bit of percent, maybe 5% or less or something like that. I think in the book they did 20 simulations, and they found one that passed, so that would have been 5%. But I think we'll stop there just because I think you guys got the point of the simulations. All right, went backwards. All right. Theoretical probability is finding the probability through math without experimenting. Right? So here we're going to write probability the same way. Right? We have event outcomes and total outcomes. We're going to do this through math. So an example was probability of rolling a 4 on a 6-sided die. Well, the probability of rolling a 4, the event outcomes, well, how many 4s are there on a die? Well, there's 1 4, so that's going to go on top. That's a 1. On the bottom are the total outcomes. How many total sides are there? 6. So the theoretical probability is 1/6. I didn't roll any dice. I didn't do anything like that, but I know the theoretical probability is 1/6. All right. Problem 3, what is the theoretical probability of each event? So A is getting a 5 on one roll of a standard number cube. So we go probability of getting a 5, and that's equal to, let's see, how many 5s are there on a die? Well, hopefully there's just 1. And then how many sides are there in a standard number cube? That's just a fancy way of saying a die or dice, which on the bottom will be 6, which is 1/6. B, getting a sum of 5 on one roll of a standard number cube. Ooh, this one's a little bit tougher, okay? All right, so first off, let's say probability of a sum of 5. Right. I think the bottom number is going to be the easiest here, and we're going to use the fundamental counting principle, which says on the bottom here, right, I have a pair of dice. Right. How many outcomes are there on the first dice? Well, there's 6, and the second one is 6. So the fundamental counting theorem says that if I multiply those together, it'll tell me the total amount together, which is 36. That's going to be our bottom number. There's 36 different combinations when we're dealing with 2 die. On the top is going to be the sum of 5. So let's come up with all the pairs of numbers that could add up to 5. Well, there's 1, 4, 2, 3, 3, 2, 4, 1. So if that's all of them, that means we have 4 different possibilities, which I can put on top. So that's my event outcomes. I'll reduce to 1/9. All right. Your homework's on page 685. We're doing 9 through 21 odd, and then 37 through 51. All right, have fun. Good luck.